Okay, so today we're going to make a program and we're going to use it to solve some problems. So here's the program we're going to make. Once you come into the program, all these windows are neat, but they're kind of clunky as far as I'm concerned. If you go to the upper left, there's a button called File, and we can open Project, and we're going to open the project we did yesterday. So that should bring it right up to there. And we open it up, and I've got all these programs because I'm gonna have to go back at some point and delete them. So I got a program. I'm gonna rename it, and this one I'm going to name Controlled Movement because I'm going to control moving the robot forward and back. Let me do some zooming things so that it makes it easier for you guys to see on the video. All right, so I'm going to control movement, and I'm going to cause the robot to go forward and back. So again, I'm going to use the move tank because that's our most common move. I want the robot to on 4 degrees, never rotations. We talked about that. And I'm going to make the robot move 360 degrees. I'm actually going to slow this guy down. And for those of you who don't listen to me and you speed your guy up, you'll pay the price later. Remember, slow is the way we go. Then I'm going to put a weight block in so that when it gets there, it pauses a moment. And then I'm going to put another move tank. And this one, again, on 4 degrees, 360. But I'm going to go negative 20 degrees for each of these. Now, for those of you who figure out what's going to happen, look, the power here is positive, and then the power is negative. So this one is going to make it drive forward 360 degrees, or one set of wheel rotations. Then it's going to wait. Then it's going to back up. That's our whole program. Oops. Let me zoom this in so that if those of you who didn't see the whole program as we went, there you go. So this program is going to drive straight forward. It's going to stop. It's going to wait a bit. It's going to drive back up. Your job is to mark out the spacing. So take your marker, and if you do this on one of the tables, you can take a dry erase marker. If you note on the robot, when we put together on the wheels, there was a little white tab, and you can use that to mark the start. So make your mark there, drive the robot, and when it stops on its way out, make a mark at that white tab again, and then it's going to come back. And then you're going to measure the distance in centimeters, always centimeters. So now I'm going to drive my robot. I don't have the luxury you guys do of having a table, but I've got a robot. So what I'm going to do is, see this little thing here? One of the reasons it was put on is so you have a marker. So I'm going to set that down. And for you guys, make a mark on the table where that lines up. And then put that and start there. Then you're going to run your program. Remember, we never run from the first tab. We always run from the second tab. So second tab, I go down and find my program. Mine was called Learning, and then I open that up, and it's got my controlled movements. It's also got the other stupid things. I don't know why they're still filling in. So I run that. Now, when I run this, I'm going to pay attention specifically to how far it goes. So I'm going to stand here with my marker, and as soon as it stops, I'm going to make a mark out here. So here I go. Watching it. Okay, it made it right there. Now, in good style, I'm actually going to run this program a couple of times. 3, this is science. We try and do things repetitively that way. So I'll run again. Still on my mark. And I'm going to run a third time. Still on my mark. So now I'm going to measure in centimeters. There's rulers in all your boxes, so this should be pretty easy. It's kind of funny. This is the only centimeter ruler I had in the house. And it's actually a little weird, but we'll just leave that alone. So centimeters. Mine says it's 17 centimeters exactly, which is pretty nice. yours should say the same thing, 17 centimeters, right? So let's do a little weird math here. I gotta move a little bit. And this kind of gives you an idea. So mine went 17 centimeters. So I'm looking for how many degrees did it take me to go 17 centimeters. Stop that. I got a dog in my face. So I went 360 degrees. To do that, it took me 17 centimeters. Now, if I wanted to find out how far to go 1 centimeter, I just have to do the math here to find out how many degrees. And believe it or not, it's not tough. Divide 360 by 17. So 360 divided by 17. That goes in there twice. So for 34. Leaves me a 20. That goes in there once. 17. And now I do some bring-ons and drop down. So I got a 3 and a 0. That goes in there twice. Now Legos, degrees and measurements, you can use decimal points, and they're very suggestible because you want to be as accurate as you can, right? So 2 there. Oh, sorry, only once. That's 17. I tried to go twice, though. Did you see that? And that leaves me a total of 13, 130. So how many times does that go in there? Probably about 8. Let me do 17 times 8. 56. 136. So it actually goes 7. And I don't really care much farther because that's pretty much accurate enough. So to go 1 centimeter, I'll need to go 21.17 degrees. And I can use this formula to help me figure out anything I wanted. So if I wanted to go 5 centimeters, I can just multiply. If I want to go 5 centimeters, I just multiply 21.17 times 5. 35, 3 carried 3, 8. That's a 5. The 2, 10. Bring in 2 decimal points, so I go 105.85 degrees, and I'll move exactly 5 centimeters. That is super useful in that I don't have to guess, and if you told me a specific distance, I could go it. So I hope that helps. Stay with this and play with this.